Questions for Adam?
Yeah, thanks for the nice talk, Adam. So I'm curious if you can test transfer learning on like the simulated Rubin LSST datasets that exist, or does it need to be real data to do that?
Yeah, so the question is, can we test transfer learning with simulated data? And I have particular strong feelings about simulated data, which goes back to sort of my first point on the conclusions here, which is that if you look at the various tools that are simulating Rubin light curves of transients, I'll leave it to that, which is an area of my expertise. I think we've done a wonderful job of understanding and knowing what is the full population of something like type 1a supernovae. And so we can simulate type 1a supernovae out to high redshifts over the full parameter space that type 1a supernovae follow. Right? But if you look at all of these tools and you say, okay, now make me a stripped envelope core collapse supernova, right? And give me the full distribution of what's observed in nature. If you look at the simulations, they don't actually look like the data. They look like some of the data, but this out of distribution problem, I think, is really important in that regard. And we can pick on other classes as well, and I'd be happy to talk about this more, but a lot of the simulated light curves that we have are not fully representative of what's actually going to be in the Rubin data. And so that's my worry for all of the various, light curve classification challenges that are out there. We should be working on those data sets, but they also are not a perfect representation of what happens in nature.
In the back there, yeah.
Hi, Adam. Great talk. What is the typical time between when ZTF, I guess, open shutter, close shutter, you get an ML score from a new nearby supernova to when you get that spectrum and it's on TNS? So that whole process, how long does that take? Is it 2 nights? Is it same night? What is it?
So typically it's probably 1 to 2 nights is the full length of that process. I mentioned that TACs hate those of us that work on machine learning. This is not exactly a TAC, but we've been fairly conservative in the way that we assign priority to the spectroscopic targets that are requested from the BTS bot. And so as a result, we are not often doing same night spectroscopy of the sources that we find. Although in principle we could. And essentially that's something at the moment that's reserved for human scanners. So the highest priority observations are triggered by humans, not by the robot. So that's the limiting step. And it's essentially a choice to be conservative as opposed to some fundamental limit in the system itself.
Very nearby galaxies, you just trigger immediately.
Yeah, so what Dave just said is you could imagine if you add some second layer filter, and this is actually something that we're building right now. So extremely nearby supernova, like what was discussed in Azali's talk, that one detection, you immediately say, oh, this is a good thing, we should go and get a spectrum. In fact, the supernova that was highlighted in Azali's talk, supernova 23 IXF, BTS bot did call this a bright supernova in the very first image from ZTF that was mentioned. But we never had that second image. And again, we've primarily been pretty conservative in the deployment of this tool. So there was no request for a spectrum at that point. But in principle, that could and should happen with future very nearby supernovae.
Okay, great. Let's thank Adam and all the speakers of this session.